Hello everybody, my name is Kyle Corey. My partner is Jake Sparks and this is Project 4 for ME416. Problem statement is listed below with the key points of our surface temperature at the start was 150 degrees Celsius and our base should have been 1 centimeter. And we were supposed to study two different materials and two different geometries. The K values for the two materials are listed below. For our hand calculations, our two geometries was a block and a cylinder, and the values for aluminum and copper for the heat flux are shown. We chose a depth of 0.11 meters, even though an optimal depth should have been 0.324 meters based off of our hand calculations. In ANSYS, we set up a thermal system. We chose a 3D thermal mass solid for our element type, and our conductivity coefficients were the only things that changed when doing it between the two different materials. We set our temperature to Celsius, and our boundary conditions are set below, including our H value and our temperature of the atmosphere. For our cylindrical fin, our dimensions are shown above for a solid cylinder, and we did a smart mesh size of 4 as shown below. For our results, we did a thermal flux vector sum, and for copper, it was 145,068 watts per meter squared, which is higher than the aluminum. This is our temperature distribution, which shows that the aluminum had a temperature of 113.5 at the end, which was lower than the copper. For a block fin, our dimensions again are shown above, and we did another smart mesh size of 4. And for our results, we got a heat flux of 101,000 for the copper, which again was higher than the aluminum. The temperature for the aluminum, however, was again less than that of the copper at the end. In conclusion, our optimal fin length should have been 0.324 meters, but our chosen depth still holds the same results. The highest heat flux will be the copper cylinder at 145,068 watts per meter squared at the beginning. The lowest temperature at the end came out to the aluminum cylinder, which was 113.5 degrees Celsius. Basically, our hand calculation showed us that once you reach that optimal length, adding any more depth to it will just be a waste of material.